Welcome to the deep dive. Today we're getting into something pretty fundamental for professional broadcasting. We're talking about a huge problem for camera ops, for engineers. How do you move a really high-quality video signal, like 3G-SDI, when you're talking about massive distances?
And that distance is really the whole problem, isn't it? Your standard copper cables, they just can't do it. Not with high bitrate video, up to nearly 3 gigabits per second. The signal just degrades, it falls apart.
It's the Achilles heel for any kind of long-haul broadcast.
Exactly.
So, okay, let's look at the solution. We're doing a deep dive on the DVIGear DVI-7345 fiber optic extender. Our mission here is to really get into the tech specs and figure out what makes this little box the gold standard for this kind of work.
And the first thing you have to talk about is just the sheer range. It's kind of stunning. The system can push a signal over a single strand of fiber for up to 1.2 miles. That's almost 2 kilometers.
Wow.
And if that's not enough, there's even an option that pushes it to 6.2 miles, 10 kilometers.
So we're not just talking about a studio floor. We're talking about covering a whole golf course, a music festival, a massive sports stadium.
Anything.
So for the pros who rely on this, what are the key standards it's built to handle?
Well, it hits all the big ones. You're looking at SMPTE 424M, which is your 3G-SDI.
The one you need for 1080p?
That's the one. And it also covers SMPTE 292M for HDSDI and the older SMTPE 259 for SD. It's built specifically for that max video bitrate, that 2.97 GBP, so you can get really deep 12-bit color.
And it's not just about the picture, right?
Right.
What about audio?
Right. When you're in 3G-SDI mode, this thing can carry 32 channels of embedded audio. We're talking 48 kilohertz 24-bit.
That is some serious, perfectly synchronized audio power going along with that video.
It is. And the way it all works is, it's just physics, really. The transmitter takes the electrical SDI signal and uses a little laser diode to turn it into pulses of light.
So it's literally just light going down the cable.
It's just light. And it only needs one single optical cable, one wavelength. Then the receiver at the other end just does the opposite, turns the light back into a perfect SDI signal.
Okay, so the performance is clearly there. But that doesn't mean anything if the box breaks in the middle of a live event. This thing looks like it's designed for the real world, not a nice, clean server room.
Oh, absolutely. It's engineered for field abuse. It's in this super compact, rugged metal box, and it uses locking BNC connectors, so you can't accidentally yank the cable out.
Yeah, that's crucial.
But there's a little detail I love. The fiber connectors, the ST connectors, they come with these metal twist-locking dust covers.
To keep the fiber ends clean.
Exactly. Dust is the enemy of optical signals.
Right.
That little detail tells you this was designed by people who've actually worked in the field.
And speaking of the field, what about the environment? That temperature range you mentioned, it seems extreme.
It is. It's rated to operate from negative 40 Celsius all the way up to 85 Celsius.
So that's minus 40 to plus 185 Fahrenheit. You could leave this thing running in the desert or, I don't know, the Arctic.
You really could. You don't need to put it in a special climate-controlled box. It just works.
Plus, you get the huge benefit of fiber itself, which is immunity to noise, right? The low RFIME profile.
Right. Radio frequency and electromagnetic interference. That means all the power lines, the generators, all the other noisy equipment on a broadcast site, none of it can corrupt your video signal.
It's just totally immune. So you get reliability, toughness, and immunity to interference.
That's the whole package.
Okay, so here's the final thought for you, the person actually designing these systems. We have a device that sends mission-critical video over miles, it's practically indestructible, and it's immune to noise. But consider this, the transmitter and the receiver, each one only pulls a maximum of 1.0 watt of power. You can power them from a simple USB port. So if you can ditch specialized power outlets and just power these units from the USB ports already on your monitors or switchers, how does that change the game for setting up a massive, complex broadcast?
That's a great question. It simplifies everything. It lowers cost. It reduces points of failure. Yeah, that's definitely food for